Alright, so we have the current box is 5 by 4 by 3. Could you calculate the volume of that current box? Okay, well, it would be 5 times 4 times 3, feet. 5 times 4 is 20, times 3 is 60 feet cubed. Okay? Alright, continuing on with the problem. The new box must be formed. Alright, so new, I'm going to draw a picture and make notes on it as we go. The new box must be formed by increasing each dimension of the current box by the same amount. Alright, so if we have a side that's 5, we must increase it plus by some amount x. And the 4-foot side, we must increase that by the same amount. And the 3-foot side, we must increase by the same amount. Determine the amount that each of these sides must be increased, and then find the dimensions of the new box. Alright, well, up here in the first part it said the volume of the new box must be twice the volume of the current largest box. If the current one is 60 feet cubed, how big must the volume of the new box be? Twice as big. So 2 times 60 is 120 cubic feet. Alright, well, let's solve the problem. We want the following. We want the volume of the new box to be 120 feet cubed. And we know that the volume, the sides of the new box are 5 plus x, and 4 plus x, and 3 plus x. And if we multiply length times width times height, we should get that 120 feet squared. So that's the problem that we have to solve. So this one's a little bit different than the ones that we did previously, because we're going to solve this by graphing, and we're going to put in our calculator the left-hand side equal to y1 and the right-hand side equal to y2. And so on the x-axis, we're going to have the x, and on the y-axis, we're going to have the volume. So let's go ahead and put this into our calculator. So I have the left-hand side of the equation in one of my y's, and the 120, the right-hand side, in another one of my y's. You can do a zoom 6 and see what you get. Now I'm looking at this, and what I'm seeing on the graph, these are all negative x values. And negative x values don't make any sense because we want to make the box bigger. We want positive x values. So I'm seeing that this part of the polynomial is going upwards. It must cross the x-axis somewhere much higher than what we're seeing on the screen. So we need to adjust this window. And we can look for clues in this equation on what we have to adjust the window to. And the first clue is this y2 equals 120. This is a constant, 120, so it's going to be a horizontal line, and it's going to cross the y-axis at 120. So I would think that we'd need to change the y-max of our window to something greater than 120. And I'm going to choose 150 for my y-max. And then I'm going to graph and the polynomial looks something like this. And we want to find where these two lines intersect, because this point that I have right here is where this volume equation equals 120. So if we find that coordinate point right there, we can find the x value that we need to get 120 volume in the box. And this is how we're going to do that. Find the trace button and do second trace to get to the calculate menu. Now instead of doing the 0, which gets us an x-intercept, or a minimum or a maximum, we want to find where two lines intersect. And so it's going to ask for three questions. What's the first curve? Press enter. What's the second curve? Press enter. And then move the cursor near the intersection, and it will give you that intersection coordinate, which is x equals 1. So this says at x equals 1, the volume equals 120 feet cubed. But that doesn't really answer the question. The question says, what are the dimensions of the new box? Well, if the x value is 1, we can plug that x value into each of these three linear binomials to get the size of the new box. So 5 plus 1 is 6, 4 plus 1 is 5, 3 plus 1 is 4. So a box of dimensions 6 by 5 by 4 will give us 120 cubic feet.